Alright, in this video I'm going to go over section 7.3, which is logarithms. We're just going to call these logs. Okay, logs are a new concept to you guys. You haven't seen them before, but we run into a problem when I have something like 3 to the power of x equals 14. And it wants me to solve for x. I would know what to do if it told me x to the power of 3 equals 14. It's easy. I just do the inverse operation, which would be a cubed root on each side. So essentially what I need to do on this one to each side is I need to do an x root. Well, an x root doesn't really make sense to us, and we don't know what that means. So we have something that comes into play when we have a variable in the exponent, and that's where logs come from. Logs are the inverse operation of having something that has a variable in the exponent. So what we're going to do is if I have something like, we actually just have a rule that tells us when we have a log with a base b, it's written like a subscript, like down below, of x equals a. What I can do to cancel out a log base b is I can put b with an exponent of this, and whatever I do to one side, I do to the other. These are going to cancel out, and so I'm going to get x equals b to the a. Okay, so how does that help me? Well, when I'm in this form, I can turn it into logarithmic form. Right now, we're just going to turn it into logarithmic form in order to get in the practice of doing it, and later on we'll use that to solve. So our real rule is when we have something in this form right here, we can change it to be b to the a equals x. Okay, you can go either way with these. So what does that mean? If I have 3 to the power of x equals 14, I'm going to write this in logarithmic form. It's going to be log base 3 of 14 equals x. Now I have the x by itself, so I can figure out what that equals. And we're not to that point yet, but we will get to that point, okay? Now, when you're doing that, if you think about it, it's saying like, let's say that I have something simple that I already know. 3 squared equals 9. I know that that's true, okay? If I turn this into logarithmic form, I'm going to make it log base 3 of 9 equals 2. 9, there's another way that I can write that so that these numbers match. The way that I can write it is, I can write it as 3 squared. In order for this to make sense, we know that this equals 2. So really, this is essentially canceling itself out, and the exponent's going to come to the front. So this exponent comes to the front, and it's 2 times the log base 3 of 3. Log base 3 of 3 is just 1. Or in other words, when you have a log with a base of the same number, that equals 1. Okay? So what I'm going to have you guys do today is I'm going to give you guys problems like log base 2 of 4 equals, and you have to figure out what it equals. In order to figure that out, we're going to have to put this as 2 to the power of something. Well, what number is 2 to the power of what gives me 4? 2 to the power of 2. This comes to the front, and this whole thing equals 1. So this equals 2. Hopefully that makes sense. If I have something like log base 3 of 1/3 equals, in order to figure this out, I have to have it as log base 3 of 3 to the power of something. So I got to figure out 3 to the power of what is 1/3? Well, since it went to the bottom of the fraction, it's going to be negative. And this is 3 to the power of positive 1, so it's going to be negative 1 right here. This negative 1 moves to the front, and this whole thing becomes 1. So it's negative 1. Realistically, what you can think of it as is when you have the same base of what you're of, the answer is just the exponent. Hopefully that kind of makes sense, okay? So we want to be able to do all of these. We want to be able to write them in logarithmic form. Okay, we want to be able to go from logarithmic form to exponential form. So if it tells me log base 2 of 7 equals x, and I want to write this in exponential form, in order to cancel out this log base 2, I'm going to do 2 to the power of. That cancels this out. I'm left with 7. Whatever I do to one side, I do to the other side. So I'm going to have 2 to the x. That's writing it from logarithmic to exponential form. If I have log base 4 of x equals 2, and I want to write it in exponential form, in order to cancel this out, I'm going to do 4 to the power of. Those cancel out. I'm left with just x. Whatever I do to one side, I have to do to the other. So x equals 4 squared. Going the other way, if I have 2 to the power of x equals 10, and I want to write it in logarithmic form, in order to cancel this out, I have to do log base 2 of 2. Those cancel out. I'm left with just x. Whatever I do to one side, I do to the other. So it's going to equal log base 2 of 10. And we're just writing them out. We're just doing examples, okay? So we're just trying to learn how to write them out. If I have x to the y equals z, and I want to write it in log form, in order to cancel this out, I'm going to do log base x. Those cancel out. I'm left with y. Whatever I do to one side, I do to the other. So I get log base x of z. Okay? These two things are inverse operations of each other. So these are for the wave 1 people. These are just the wave 1 stuff. But you guys are all going to have to get there. So if I give you something like, if I give you f of x equals log base 2 of x, and I tell you to write it in, find the inverse. So the first thing we're going to do is we're going to change the f of x to y. Then we're going to switch the x and the y, the same as what we were doing the other day. The opposite of this log is, I'm going to do 2 to the power of to cancel these out. Whatever I do to one side, I do to the other. So I have 2 to the x equals y. And then I just rewrite it as the inverse of f of x equals 2 to the x. And that's our answer on that guy. Okay? So when we're doing the inverses, we're only going to be doing them on a wave 1, but when we're doing the inverses, that's what we want to be able to do. Okay? So if I give you something like f of x equals log base 5 of x minus 10. First thing, you're going to change it to y. And then you're going to switch the x and the y. You want to get rid of this log, so you're going to put 5 to the power of. Those cancel out. Whatever you do to one side, you do to the other. Since there's nothing happening outside of this, we don't need the parentheses, and now you're going to add 10. And then we just want to rewrite it with the inverse. 5 to the x plus 10 equals the inverse of f of x. Okay? Logs are a new process for you. I know that you guys haven't done them before, so we just want to get used to doing them. We want to get used to going from logarithms to exponential and from exponential to logarithms, okay? There are a couple of rules that we really want to remember. The first one is that when I have something like 5 to the power of log base 5, that they cancel out. I really want to remember that, okay? The other thing is when I have something like log base 5 of 5, this equals 1, okay? So those are the two deals that I want to do, all right? Now the last thing that I want to talk about is if we think of anything to the power of 0, if I think of something like 3 to the power of 0, we know that that equals 1. So let's reverse solve that and get it in log form. So in log form, this is going to be log base 3. These are going to cancel out, and we're just going to have 0. Whatever I do to one side, I have to do to the other. Log base 3. So this tells me log base 3 of 1 equals 0. Well, let's do another one. 9 to the power of 0 equals, and we know that that equals 1. All right? So when we do that, we're going to say log base 9 on each side. these are going to cancel out, and we're going to have log base 9. Oh, I'm sorry. This side's going to be 0. Log base 9 of 1. Now notice what's the same on both of these. They're both of 1, and they both equal 0. So whenever you have something of 1, it's going to equal 0. The log base anything of 1 is going to equal 0, always. Okay? So that's one rule that we want to remember. The other rule that we want to remember, log base anything of itself equals 1. And that's because if we put it into exponential form, right, it's going to tell me b equals b to the 1. So this is always going to be true. And we already know that. If there's no exponent, show that it's a 1. Okay? So we want to remember both of these rules. The log base anything of 1 equals 0. The log base anything of itself equals 1. And those are two really important rules. Okay?